the last video, we looked at how to build with the sun in mind. In this video, we look at how to design and build building envelope to resist variations in outdoor temperature. Houses in temperate Australia must deal with a wide range of temperatures. When there is a difference between the indoor and outdoor temperature, heat will flow through the building envelope. The greater the temperature difference, the greater the heat flow. In winter, heat will be lost from the building, and in summer it will be gained. To reduce the heat transfer, it's crucial to have insulation in the roof and walls, and also beneficial to insulate timber floors. Insulation keeps heat inside in winter and stops heat getting inside in summer. The R value is a measure of how well the insulation will reduce heat flow. The higher the R value, the better the performance. The regs might ask for a system R value or an added R value, so you need to know the difference. The timber, brick and plasterboard also have an R value, which can be added to the R value of the insulation to give a system R value. The R value of the insulation itself is called the added R value. Only system R values are quoted for reflective insulation, as it depends on how and where it is installed. Getting the glazing right is critical for ensuring indoor comfort. The words label contains all the information to make an informed choice. Look not only at the star ratings, but at the U value, which tells you the level of the insulation. The lower the U value, the better the insulation. This is the opposite way around to R value of insulation. Standard 3mm glazing has a U value of about 6, which allows up to 10 times more heat through than an insulated wall. This home uses double glazed windows with a U value of 3. Higher performance glazing, such as low E double glazing, has even lower U values. Other measures on the label, such as SHGC, are also important, so do not base your decision on U value alone. See the previous video for information on this. And it's crucial you install glazing that complies with the building code and planning approval. Frames are an important consideration. Choose only timber frames or aluminium frames with a thermal break, which is a layer of insulation to reduce heat transfer through the frame. A well-insulated building envelope is of little use if it's not well sealed. A leaky house might have 20 air changes per hour. The air inside gets replaced every few minutes. Drafts like this are a problem in cold weather and also in hot weather. Make sure you've got good seals on doors, windows, chimneys, exhaust fans and recessed downlights. There'll be still enough fresh air to keep people healthy. Ventilation can provide effective cooling when the outside temperature is cooler than the inside. Allow cross ventilation by locating openings on opposite sides, with minimal obstructions in between. This will allow in breezes on cool summer nights to flush out the trapped heat. Design and orientate your building to capture prevailing breezes and choose windows with a large openable area. But ventilation can't cool a building on hot days, so it's good to have insulation and draft proofing that let you seal the building and keep heat out. This avoids or reduces energy needed for air conditioning. With a well-insulated, sealed and ventilated home, thermal mass can even out maximum and minimum temperatures inside a building over 24 hours. Mass doesn't create heat, it just stores and then releases. In winter, you need mass exposed to sunlight, which will warm up through the day and then release warmth in the evening once the sun is gone. In summer, mass absorbs heat from the air to keep the temperature down during the day, and it releases it at night when it can be flushed out by cool breezes. A concrete slab or internal masonry walls are the easiest ways to provide effective thermal mass. A slab on the ground takes advantages of the Earth's mass to even out indoor temperatures throughout the year. So, to design and build a comfortable home, insulate to reduce heat gain and loss, use seals to prevent drafts, provide openings for cross ventilation, and use mass to even out the temperatures. As you can see, it doesn't have to cost more to build a lower energy home, just a little bit of know-how. For more information, download the fact sheet at tradesecrets.org.au.